polar, cylindrical, spherical. So like cylindrical, you add the r, and so forth. So you have r world squared sine phi. Okay. Formula for a Jacobian. Okay. And there are certain formulas, for instance, the linearization, directional derivative, I'll put those there, but for instance, for max-min problems, it's up to you to know how to classify max, min, saddle point. Okay. I may, if it's convenient, put something on there about the chain rule, but the chain rule has all these different scenarios for how many variables you have. But okay, so all right, so you'll have something pretty comprehensive there. Okay.
They're 5 points each. So what if you get like half the problem, then you only gonna do the partial credit?
I always do. Yeah, so I haven't been this explicit about partial credit, but the way it would work is, for instance, if you make a mistake, if you don't get yourself the right answer, but it looks like you did know what you were doing, and just made a careless mistake, that would cost you 1 point. If it seemed like there was some lack of understanding, 2 points off. If it seemed like you didn't really know what you were doing at all, but at least made an effort, that's 3, and then beyond that, you don't get anything. No. So that means it's really hard to get a score below a 40. But it also means really don't leave anything blank. Please don't leave anything blank. Okay. No.
So you've got like a smiley face or something under a problem you don't know how to work.
Depends on my mood at the time for something like that, but you definitely, if we're talking about the difference between 0 and 1, in that case. Yeah. Okay.
We're really doing all 24 problems. I only got 173 minutes on this recording part here.
Oh, okay. Well, there might be some that are less nasty that we could leave out.
Might
Like-
want to start
yeah,
with
like-
something.
Like in chapter 11, there are some that are involved in like chapter 13.
Yeah. Well, yeah. So, for instance, like definitely do a Lagrange multiplier, something like that. Okay. So, well, how about this? Since this stuff is going to be fresher in your mind, we'll go back to the beginning and pick some problems from there. Okay.
Oh yeah, that's right. We got the YouTube videos and the DVDs people can look at, right? For the problem examples, or
Well, yeah, there's always that, but then there's a lot to sift through. So,
no, true.
but yeah, we could look at the review sessions, for instance. That would be a little more efficient. Okay. So how about this? Tangent plane, normal line. I don't think hardly anybody missed that one on the first exam, so I'll skip that one. Okay. Here we go. All right. So, sorry, I'm going to take down your little ad here. But I think anyone watching this knows. So if I get assigned to teach this class again, maybe I just won't even show up. We'll just show up videos.
Yeah.
All right. All right. Oh, okay, here's a good one. suppose you have, this is about linearization. So we have x, y, z, x squared plus y squared plus z squared. So find linearization at this point, 3, 2, 6. By the way, this is Stewart's 11.4, number 17. Just going to follow along with that. So find linearization at this point, and then you estimate the function's value at 3.02, 1.97, 5.99. Which you can see is close to that point. So linearization of f at any given point is given by the function value at that point. Oops, that should be a z. Plus partial with respect to x, also at that point, times x minus x naught, plus fy, y minus y naught, plus fz, z minus z naught. So we've seen the partial derivatives at that point. So what we have is fx, we're going to have 1/2 x squared plus y squared plus z squared to the minus 1/2 2x. So it's going to be x over this. Similarly, we're going to have fy, it's going to be y over this. And fz. Okay. So now, we just need to do a whole lot of plug and chug with this point here. So function value, so you get 9 plus 4 is 13 plus 36 is 49. Oh, okay. So f of 326, square root of 9 plus 4 plus 36, which happens to be square root of 49. So that worked out way too nicely. So we'll have 7. So the partial with respect to x, it'll be 3/7. The x value is 3. X minus 3 plus 2/7. X minus 2 plus 6/7. Oh, sorry, that should be y minus 2. 6/7 times z minus 6. Okay. So that's the linear function that approximates f near this point. So now, to get the approximation of f at this point, we compute the linearization of 3.02, 1.97, 5.99. So that's going to be equal to 7 plus partial with respect to x times the difference between the x value at your new point minus the x value at the old point. So it's going to be 0.02 plus 2/7. This minus 2, so that's going to be minus 0.03 plus 6/7. This minus 6, so it's going to be minus 0.01. So once you work all that out, then you get